So guys, we have always been able to simplify negative square roots, okay? When the negative is on the outside, like negative square root of 40. But until now, we were not able to simplify square root of a negative when it's on the inside, like that, okay? Notice the difference between the two. In order to simplify the second one, the square root of a negative 20, we need to use imaginary numbers. So our definition of imaginary number is I equals square root of a negative 1. Yes, so we have to understand, we have to know this, okay? Definition of a complex number. Complex number is going to be a mixture between a real number and imaginary. Complex number can be written as a plus bi, where A and B are real numbers, and I is your imaginary numbers, okay? We can even graph this out, guys. You're gonna learn more about this later, but when we graph out imaginary numbers, the x-axis is called the real number axis, and the y-axis, guys, is called the imaginary number axis. So instead of x's and y, it's called imaginary. So I'm going to give you a complex example. So in example, 4 minus 2i. So your 4 minus 2i's, this is a positive, this is a plus negative bi. So a is 4, so 1, 2, 3, 4. And we have your negative 2i, that's going to go down, 1, 2. So when we put a dot, that's what happened when we have 4 minus 2i. And we can even, some books will even connect this from the center, okay, like that. We can also do another one. Let's do another one. What if we have negative 1 plus 3i? Okay, then that means your real number is negative 1 on the left side. Your imaginary goes up 3 because it's 3i. 1, 2, 3. And this is going to be your negative 1 plus 3i. And again, some books will make it a dot. Some book will make it this vector, just like that. Okay, you don't have to worry about graphing. Conjugate pair definition. Two expressions that are identical, except for the sign between them, So keep that in mind, okay? Example, okay, so raising powers of I, okay? So I to the first power, students, is going to be I. I to the first is I. I to the second power is the same thing as I times I, that's I to the second, or we can't leave it like that. We have to simplify further. So that's going to be I, remember, I is square root of negative 1. So if I times I, we can look at it as negative on the inside, so square root of negative 1 square, okay, like that. So that means we can get rid of your square root. So I square equals negative 1, okay? So I to the first is I, nothing we can do about it. I square is negative 1. Now I to the third, students, is the same thing as I times I square. Well, I is I, not much we can do with that, but I square is going to be a negative 1. So this is going to be a negative 1i, or we just write it negative I. So I to the third, student, when we simplify it out, is negative I. So I to the third is negative I. I to the fourth, students, is going to be I square times I square. Or we can think of I square to the second power. Well, I square from here, that's negative 1 times negative 1, or negative 1 square. So that's going to give us a positive 1. So I to the fourth is positive 1. Isn't that amazing? Yep, that's how we simplify I's power. I to the fifth, guys, I to the fifth is going to be I square times I square times I to the first power. Well, I square is negative 1. Negative 1 times negative 1 times I. So -1 times -1, +1. So 1I, or just simply I. So I to the 5th is I. Whoa, wait, are we looping back around? Okay, maybe it's just a coincidence, right? Let's go and simplify the next one. I to the 6th. So I to the 6th, we can make I squared times I squared times I squared, because when you multiply, you add your exponents, or you can go I squared to the 3rd. Okay, either way is fine. Now, if you go I square, I square, I square, guys, I square is always -1. So -1 times -1 times -1. Well, -1 times -1 is going to be a +1. +1 times a -1 is going to be a -1. So I to the 6 equals -1. And then let's see. Whoa, we're looping back around. Can you guys see that this is -1? Well, let's see what's happening. Okay, do we ever have anything new? So we have I is I squared is -1, I to the 3rd is I to the 4th is +1, and then we're kind of looping back around. So I to the 7th, we can think of it as I to the 6th times I, right? Or I to the 1st power. So I to the 6th is -1, so -1 times I, so that's going to be a -I. So I to the 7th is going to be a -I. And let's do one more to see if we have anything that's not already found. Okay, so I to the 8th, guys, we can think of it as I squared, like 4 times, right? Like this. Okay, and each I square is always -1. So we can go -1 times -1 times -1 times -1, which is a +1. Or if you don't like writing it 4 times, you can write I squared to the power of 4, which is going to be the same thing as -1 to the power of 4. Any negative number to the power of 4 is always going to be positive. So I to the 8th, students, is going to be a +1. So let me pinch it in really quickly. Do we have a pattern? So I to the 1st is I squared is -1, I to the 3rd is I to the 4th is 1, I to the 5th is back to I, and then I to the 6th is -1, I to the 7th is I to the 8th is 1. So it looks like after the power of I to the 8th, we're looping back to I. So as you can see, we know that every 4 it repeats, okay? So that will help us out with a couple of different patterns, okay? So if I say I to the 9th, we should be able to find this really easily because we know it repeats after the 4th I. So 9th power, what you want to do is 2 ways. I'm going to show you how to do this 2 ways. You know it repeat after every 4th, so you're going to take 9 divided by 4. 9 divided by 4 is going to give us a 2. 2 times 4 is going to be 8, and then we're going to subtract. We're going to have 1. This is your remainder, okay? This is your remainder. If your remainder is 1, then I to the 9th is going to be I, because it's the first value, okay? So let's do this one, I to the 10th. Take 10 divided by 4. That's going to give us 2. 2 times 4 is 8. Your remainder is going to be 2. If your remainder is 2, then I square. So that means this I to the 10th is going to be -1, and so on and so far. If your remainder is 3, then it's going to be -I. If your remainder is 4, then it's going to be +1. My apologies. I meant to say if you have no remainder, okay? If you divide by 4, you shouldn't have a remainder of 4. If you have no remainder, then your final answer will be a 1. Let's try this out. And I'm going to show you a second method as well. So simplify. Example 5 to 8 simplify. I to the 15, okay? So we're going to say I to the 15. Let's take 15 divided by 4. We're going to try 3. 3 times 4 is 12. you're going to subtract, which is 3. So your remainder is 3. If your remainder is 3, we're going to go up. This right here is what you look at. Okay, so your remainder is 3. I to the 15 students is negative I. And this is what you box up. Secondary method. Whichever one's easier for you, that's what you need to go with. Okay, I like my second method more. I to the 15, it's the same thing as me saying I to the 14th power times I to the first power. 14th power, guys, is I square to the 7th. Okay, that will give me power to the power you multiply, and that's going to give me I. This method right here, the second method, I don't need to know the division part. I know that I square it's always going to be -1 based on that. So this will allow me to say -1 to the 7th power times I. Negative number to the odd power is always -1. So -1 times I, students, is going to be -I. So either method will give you the same answer.